All right, the last one I'll do from the Chapter 9, Section D1 exercises, the practice exercises, is the fourth problem in that set. It starts with a universal statement for all x. If mx, then lx. All right, then another universal statement for line 2 for all x. If lx, then nx. I haven't even gotten to my conclusion yet, but I would be surprised if this is not going to use a hypothetical syllogism, since it seems to line up so well. You have the Lx as a consequent, you have the Lx as the antecedent, or the C, but that's my immediate suspicion. So what is the conclusion I'm supposed to reach here? I haven't looked at that yet, but yeah, okay. It's for all x, if mx, then nx. And I was right. If I'm looking here, I see the mx, I see the nx, I look over at my premises, yeah, there's mx, there's nx. You see the obvious connection between them. This is perfectly set up for hypothetical syllogism. But again, that's a rule from chapter 8. You can't use it on a quantified statement, so you gotta get rid of those quantifiers. So we're gonna have to instantiate before we can do the hypothetical syllogism, and then we'll have to reintroduce the quantifier through a generalization. All right, we'll use universal instantiation to get rid of the quantifiers here. I notice here I'm looking for a universal statement in my conclusion. That tells me that when I get to the end of the proof, I'm going to use a universal generalization. You can only do that on a free variable. So when I instantiate here, I want to drop off the universal quantifier, but I don't want to put a constant. Instead, I want to leave a free variable so that I can use universal instantiation at the end. All right? And it doesn't really matter what variable you use there, but I'll just use x since we already have it with x's. So first I'll get rid of the quantifier on line 1, right? Universal instantiation. Right, so that is, line 1 says it's true for everything, and this just really says pick any arbitrary x you like. It'll be true for that. Right? Which amounts to the same thing, which is why you can go between them so easily. You could, immediately, if you wanted to, use a generalization, get right back to the first statement. So that is, again, from line 1, universal instantiation. Right? Now line 4. I'll also drop off the quantifier on line 2, if Lx and Nx. And again, you can choose whatever variable you like. Will you instantiate here to a free variable? I'm using x. I do want to keep it the same, right, between these. And I can, because it applies to everything, so it's guaranteed to apply to this, whatever this thing is. This is just an arbitrary thing. But since these statements are true of everything, they'll be true of any arbitrary things. So they'll be true of the same arbitrary things. And I need that free variable to be the same so that I can do my, so that this is the same as that. Right, so I had the Lx on both sides. So that it was line 2, universal instantiation. Right. Now I can do hypothetical syllogism. If mx, then nx. From lines 3 and 4. Hypothetical syllogism. Right, there you go. And then now that I've done what I want to do, then I finish up with my generalization. So I'm just going to introduce again the universal quantifier for all x. If mx, then nx. Right? And that's just from line 5 through universal generalization. Because I had that free variable there, I'm allowed to do that. All right? And that is the proof. And very straightforward. These proofs from section D, I can't guarantee they'll all be very, very easy, but they're not too challenging once you see the general pattern. Lots of times, again, you're just going to be instantiating so that you can use those old familiar rules from chapter 8. And then if you need to get back to some quantified statement, you don't always have to. We've seen them before where we didn't need to get back to a quantified statement, like up here with CA. But down here, we needed that, so we used the generalization. And when you think through what kind of generalization you're going to be using, it tells you a lot about how the instantiation needs to go. All right, hope that helped.